Good day, everyone, and welcome. I'm Kathy Mayo, Executive Director of PODS Association, and it's really good to be with you again today. Today is Unit 5 out of 6 units of PODS Basics, and today it's analysis of pipeline data. We did slightly adjust the title from what we had originally advertised, but stick with us. I'm sure you're going to find a lot of good information. I've just been really excited about Julie Parker's presentations. She's with Teach Me GIS. So joining me today is Jackie Smith, President of PODS Association Board of Directors. Jackie.
Hi, welcome everyone. Glad to see everybody in this morning. So this is our 5th training session to increase awareness of PODS, to get everybody educated and aligned. I want to encourage you to send feedback. There's a survey that will be distributed. Please send your honest and critical, if you'd like, feedback, and hopefully it's positive, but we are open to anything you need to say, and to make this better, we want to continue to improve our sessions and continue to get the training out throughout the year. And also we may do this in the fall. So we're looking at planning our fall conference. We are looking at planning it virtually. As many of you know, our fall conference is usually in September, October timeframe. And with those state of the events in the world, we're still thinking virtual is going to be the way to go. So we have a great presentation for you today. And then at the end of this session, we also have a vendor, what we call lightning talk, and will actually be presented by Rosen, which is myself and one of my teammates. Anyway, so I'll give it back to Julie for the training session. Thanks.
Thank you, Jackie. Hi, Julie. It's good to welcome you. Most of you are familiar with Julie. Again, I just welcome her. I'm excited about what she brings to the table for PODS Association and this PODS Basics training. And she's just so well versed in the topic, has tons of experience that she brings to the table. And with that, I'm just going to turn it over to you, Julie. And again, welcome.
Thank you. Thanks. Good morning, everybody. Happy Monday morning to you. Welcome. So this is our next to the last session together. And this one is going to be covering analysis. Originally, we were going to just focus on spatial analysis, but there's just such a whole other world of analysis and other topics that kind of need to fit into this, under this tent that is analysis of PODS data, that we decided to broaden the topic. So at some point in the future, we may do a deeper dive on just spatial analysis, but for today, we're going to look at spatial as well as tabular analysis. So now that I've said good morning, I'm going to turn my webcam off and we'll get started with the presentation. Okay, so hopefully you can see. So this podcast, or this PODS presentation is it's intended for GIS or IT professionals. Certainly people that have an initial interest in PODS and just simply want to learn more about it. If you're new to the pipeline industry, perhaps you've recently joined the industry and you've had little or no exposure to PODS, this is a good place to start, just to get your feet wet and to kind of get a good foundation for future learning. So moving on, this is Unit 5, as Kathy said, of 6 units. Our next one will be on PODS implementation. So if you happen to be in a company that is considering implementing PODS, you'll definitely want to make sure that you tune into this one, and also anyone else in your organization that might be working on implementation. This will be a really great session to end our series on. But today we're going to focus on just the analysis components of pipeline data. So as you can see, here's our lovely PODS model. This is the 4.02 version of the model that we looked at in more detail last time. But I wanted to just kind of reorient you to the model and thinking about the model and how the tables relate to each other and what the overall purpose is of PODS. So by this point in the series, I really hope that you're realizing some of the benefits of the data model for storing and managing our pipeline system data. We focused a lot of our attention on the ways in which PODS improves data organization and quality, integration, and certainly efficiency. Today, our attention will be extending on the usability of PODS data. So one of the things that we need to visit about is yes, we've been talking about the PODS model. We've been talking about how the tables relate to each other and lots of different components of why you need PODS and so on. But we haven't spent any time talking about what you actually do with PODS once you get it installed and you get data loaded into it. And I need to clear a misconception that might be out there that PODS is everything, the container, the analytical tool, the reporting tool. It's a one-stop shop, and that's not the case. So I want to make sure you understand that when you see the PODS data model or when you consider PODS, it's the container for your data. So you're going to need additional tools that come from third parties. There's many vendors out there, many specialty vendors that focus on certain aspects of pipeline data management or certain types of operations. So these type of vendors are the resources that you'll seek out once you are in the process or begin the process of implementing PODS. In many cases, you'll actually seek the help of a third-party vendor to maybe convert or do data management practice before implementing your data or integrating your data into the PODS data model. So just understand that PODS is a stealthy container for your data, but unless you use other tools in conjunction with it, it's going to just be a container and nothing more. So you'll never realize the true value of PODS without these third-party applications. So I'd like to take some time to just kind of sort things into buckets, if you will, for how and what is connected to the PODS data. To the PODS data model. So many types of pipeline management activities are improved and integrated when PODS is integrated into a business. So PODS often becomes the system of record or the authoritative source for the organization's pipeline data, as well as the hub for all the pipeline-related data connecting to in-house applications, as well as many third-party software applications. So what I'd like to do is look at four groups of applications, if you will, or four usages of data within the PODS data model. So this is going to be looking at those applications dealing with data quality, data accessibility, data analytics and reporting. Certainly operational integration as well. So these are four main areas that a PODS data model serves in an organization. And we're going to step through these various applications so you get a really good idea of many of the different activities and services that are performed under these various headings. So let's move on. So if you've been with us for previous units in this series, you'll remember the concept of linear referencing. It's how PODS data becomes spatialized. So it becomes viewable. It also is able to be analyzed with geospatial tools. So just to reach back a bit, I'll redefine linear referencing for you. So it's mainly when a singular linear feature, for example, a pipeline is used as a reference. The measurement of that pipeline is used for locating additional pipeline features and all the characteristics of those features along the length of that line. So it begins with the center line, which is the core of linear referencing. And then all the ancillary features of that pipeline or assets of that pipeline, the valves, the meters, etc., are placed by referencing the measured center line distances. Remember, in linear referencing, these additional features that are linearly referenced can maintain their own internal measurement systems, but they are referenced to the Earth's surface by using the measurement system of the center line. You'll also recall last week's exploration of the data model's conceptual and logical diagram, in which we saw the related tables that are connecting data elements for all the aspects of pipeline data management. So you may recall this graphic that we had last week, just showing the different relationships that exist between tables in the PODS data model. And also you might remember the cardinality, the type of relationship that exists. So we won't go back into that again, but I just wanted to toss that vocabulary back out to you so it sticks. So let's take the very first heading here, which is data quality. And let's talk about one of the first items that falls under that realm. Alignment sheets. So what you're seeing before you now is what we call an alignment sheet. And this one is a very good example because it's on one sheet, it's giving a tremendous amount of information. So alignment sheets graphically show the exact route and the location of the pipeline and its associated facilities. Much of the knowledge that exists about that pipeline during the design phase often accompanies the graphical information on the sheet. So therefore, you'll see that there's a vital set of documents for maintenance. These are vital for maintenance, for recovery purposes, for location of assets and things of that nature. They're very valuable documents that tend to live with the documentation of the pipeline. Different sets of alignment sheets are typically made during a pipeline's planning, construction, and operational phases. So there may be an initial, maybe during the permitting phase, you'll see one set of alignment sheets with the proposed route and different features surrounding the proposed route and other notations on the sheet. And then once a pipeline is constructed, you'll see a post-construction alignment sheet, which is really important, certainly for repair purposes and inspection purposes. It shows the pipeline as it exists in the ground today. So alignment sheets are generated by third-party applications that are connected to PODS. So everything you're going to be seeing in terms of these capabilities are all being fueled by the PODS data model. So one thing you might be wondering is this length of pipe that you're currently seeing right now is only one segment of a pipeline. How does this represent an entire system that may be many miles long? And the answer is contiguous sheets. So typically there will be additional sheets for the subsequent sections of pipeline or the adjacent segments of pipeline to this one that you're viewing right now. And there's usually some type of way of matching these together so that there is a type of continuity there. So you'll see that the scale will oftentimes remain constant as the different sheets are generated. There's software available that actually will create alignment sheets for every segment of the pipeline. Put them all in order, get them into PDF format or whatever format that you may need. So on the next part of this assignment or data model area, we're talking about the fact that GIS teams are often managing PODS data. In many companies, you'll see GIS-enabled software and platforms that are facilitating the spread of pipeline data across entire organizations. And this is a great example. Here you can see a dashboard of this area of pipeline on your screen. You can see information, you can see a tabulation of corroded areas versus those that are not corroded. You can see changes in depths, comparison of anomalies in the data over time, and so on. So just quick little dashboards that are deriving information from PODS and putting it in an easily digestible, meaningful format for users. We'll get to this in a little bit, but I'll give you a little bit of a preview. These applications, these GIS-enabled applications also spill over into the mobile environment. So there are many different applications that allow teams to go out with a handheld unit of some type, maybe a data collector, maybe a full-on GPS unit to collect or update data. And so this screenshot is just an example of that. And we'll talk a little bit more about that later. Of course, there's always going to be maps associated with GIS. And so here you can see just an overview of a basic map of a route of pipeline. And also some analysis. So you can see the data tables here that are tied to this particular pipeline that's being analyzed at the moment. And you can see the results of an operation there in GIS. So GIS is a very strong part because the spatial component of PODS is very strong. These pipelines, as we talked about in our very first session, don't exist in a vacuum. They exist in an environment, and they have locations, and they have all types of features surrounding them that have to be viewed and worked with in a spatial fashion. So most large companies have an asset management software, and PODS also connects to this type or these types of software. So this software, of course, is used for managing physical assets such as equipment and buildings, plants, machinery, vehicles, and whatnot. Two of the most used applications are IBM's Maximo, you may have heard of that one, or SAP's EAM software. So these are applications that most major companies use to track their physical assets. So physical pipeline systems are certainly assets of the operator, and also all the associated facilities are physical assets of the companies that own them. PODS can be connected with asset management applications, providing updated information on the pipeline assets without unnecessary duplication of data. Asset management applications will also manage data regarding maintenance, work orders, inventory, reporting, and lots more. So here in the gold boxes, you can see several different examples of the types of information that you might find in an asset management system connected to PODS. So one term that you may hear is MAOP. And so we're going to dive into this just a little bit because there are a number of analytics and reporting functions that are supported by PODS. The Energy Transportation Network of the United States consists of over 2.5 million miles of pipelines. That's enough to circle the Earth about 100 times. And that's crazy. That's just in the US alone. These pipelines are operated by approximately 3,000 companies, large and small. The Pipeline and Hazardous Materials Safety Administration is the federal agency charged with safe and secure movement of hazardous materials by all modes of transportation. The agency also oversees the nation's pipeline infrastructure. So if you're interested in learning more about the PHMSA, as it's called, organization or agency, it's the Pipeline Hazardous Materials Safety Administration, PHMSA. You can find them on the web. You may have recently heard PHMSA is revising the federal pipeline safety regulations to improve the safety of onshore gas transmission lines. This final rule addresses congressional mandates, National Transportation Safety Board recommendations, and response to public input. A recent PHMSA regulation requires operators to provide confirmation of their MAOP values. Operators using PODS will be able to use various data analysis techniques to carry out their compliance activities. So MAOP in this instance is what we call the maximum allowable operating pressure that a pipeline is sanctioned to operate at. And that's going to vary depending on what the pipeline is made of, as well as the thickness of the pipeline, the diameter of the pipeline, and so on. So for all segments of pipeline, there's going to be a pressure, maximum allowable operating pressure set for that particular pipeline segment. So this is important. It's a primary consideration in terms of public safety, and certainly for the operators, having the correct pressure for your pipeline segments means that that pipeline can transport its cargo, so to speak, with great efficiency. So it's important that the operating pressure is correct for the pipelines and monitored. This information is stored in the PODS data model. If you get a chance and you still have access to the model that we looked at last week, see if you can find it. So another aspect of data analysis is in the reporting of risk and integrity of the pipeline. So pipeline safety regulations include requirements for operators of hazardous liquids and other natural and other gas transmission, as well as distribution of pipelines, to develop and implement comprehensive integrity management programs. An integrity management program is a set of safety management, operations, maintenance, evaluation, and assessment processes that are implemented in an integrated and rigorous manner to ensure that operators provide enhanced protection for high consequence areas. So we'll talk about HCAs next, but these tables that you see before you are part of the PODS model. So you can see there are areas to store information in PODS that are accessible by other applications that you can use to run analyses on your risk and integrity. So you can also see there is a separate, in this particular version of PODS, there are risk tables. There's also a place to store repairs that have been used or done on a particular pipeline segment. So there are areas within the model that are storing this type of information that will need to be referenced in order to do analysis of the pipeline to maintain safety and integrity. So an integrity management system is a set of safety management, operations and maintenance, evaluation and assessment processes that are implemented in an integrated and a rigorous manner to ensure that operators are providing enhanced protection for high consequence areas, or HCA for short. A high consequence area is a legally defined area, and it's especially an area that is especially vulnerable to damage in the event of a pipeline leak or a failure. Operators use a graded method of class locations to identify areas of population density where increased levels of safety precautions may be needed. So as you can see in the graphic here, some of the areas that would be considered high consequence areas are populated places, areas where there are drinking water sources, if there are any sensitive ecological areas, and certainly areas where there are very dense populations. All of these require increased safety and risk management activities. PHMSA's Office of Pipeline Safety monitors operator compliance with, through field operations and field inspections of pipeline facilities and construction projects. Inspections of operator management systems and procedures and their work processes, as well as incident investigations, all fall under PHMSA's purview. Operators must follow safety rules to maintain and supply documentation, cooperate with inspections, and accident investigations. So compliance is also a very large component with many tables, as you can see in this version of PODS. Newer models will look different from this, but again, we're dealing with our model we've been looking at through class, which has been 4.02. So if you want to see newer models of PODS, different models of PODS, you would need to see where these areas are treated within the model for the PODS version that you're working with. Needless to say, though, compliance activities garner a significant amount of table space, and they're important because there's a lot of permitting and lots of regulations that are around all of this information. So it needs to be accessible and it needs to be easily analyzed. So we talked a little bit about as-builts early on. We talked a little bit about the alignment sheet, and I mentioned that there's pre-construction ones, and post-construction ones as well. And what you're looking at right now, highlighted here in the highlighted area, is the as-built information. So these as-builts then are done after the pipeline is in ground. It's been constructed, and this alignment sheet post-construction then contains all the measurement data and locational references along that pipeline. So you can see in the highlighted area, here are all the measurements and stationing points along this particular section. So again, additionally, on the operational integration front, we mentioned briefly at the beginning of this unit about mobile devices and how they are oftentimes connected through GIS. In this case, I'm showing you an example of a mobile application and just kind of stepping you through the field data collection process. So as you can see in step one, we've got a gentleman that is in position in field. He needs to capture on his mobile device information about a pipeline segment that is going to be used as part in construction. So he is taking a photograph of the markings on the pipeline, and I won't go into all the detail about what those markings are, but he's capturing this information. he's adding more specific information about the diameter of the pipe, the grade of the pipe, and so on. And then he's uploading it into a mobile application. So you can see in step 4, he's transmitted that data, he's saved the data that he has gathered on site. This data would then be used to update the PODS database with. So this is how you see the influence of geographic information systems. And you also see the PODS data model working in tandem with each other to give a complete picture of this pipeline and all the associated segments. So on the analysis side, we'll leave the groups of analytical capabilities and practices that are done with PODS data and turn a little bit now towards the analysis of PODS data. So by now, I hope you're getting a good picture of the various different facets of analytical capabilities that exist when you have your data in PODS and you're using third-party applications that fit the needs of your organization as well as your regulatory requirements. So your analysis of PODS data then is made easier because you've got your data in a standard database and it's easily accessible. We've already talked about the fact that your data is governed. There is data quality data quality enhancements that exist in the PODS data model as well, so that you're able to take advantage of reporting and other types of statistical analysis that you need to do in association with your reporting functions. So in this case, you're looking at just a couple of different analytical products that are used with PODS data that's been gathered. Maybe some of it has been gathered before a pipe went into the ground. Maybe in some cases, we're looking at historical information and so on and so forth. But the most important thing for you to get right here is that asking questions of your data and getting these answers back in the form of a map or a chart or a dashboard or something of that nature is really powerful. And it wouldn't be near as powerful without the data that's in PODS. So here are some examples of some typical analysis questions that you might pose to your PODS database. Typically, PODS database questions, so to speak, or queries will be asked programmatically, sometimes through software or through user interaction with some sort of third-party tool. Output from data analysis might be a paper report, might be a spreadsheet, might be a digital dashboard. There are lots of different ways to view the output from data analysis. In this screenshot, what you can see is a shot provided by a third-party vendor, and this is one way that they are asking their users to be able to query PODS data. And here's some examples of some questions that they might typically pose. But what you've got here is a query on inspection data, and you're actually able to use drop downs and mathematical operators to filter and refine the results of your query to the PODS database. So this application connecting to the PODS database then gives you the tools to customize a query or a question to that database and get the results that you need. Software certainly is helpful for performing analysis on PODS data tables. You're not going to be doing a whole lot of work without some sort of additional software. Here's some other examples of some vendor analysis tools. These tools are from ONG and from Pivot, and they connect directly to PODS data, where they perform analytical tasks on PODS tables. So in the image that you see on the left, the query is looking for coding defects. Are there coding defects here? And you can see the interface is quite sophisticated. You can see an image of the pipeline corridor. You can also see a photograph of the area, and you can see the physical markings of the right-of-way for that pipeline, and then you can see an overview map of where this is in space. And then you've got all these widgets along the side here that allow you to manipulate the data in such a way that you get the information that you're looking for, either through a query or through maybe even just changing the colors of the symbols and symbolizing by certain values that exist in the database. On the other side, the right side of the screen, you can see a route analysis. And this is a really interesting spatial application because before a pipeline is in the ground, there has to be a route approved and decided upon and planned and surveyed and everything else before anything happens. But when there's the first inkling that there's going to be a pipeline required in an area, route analysis is a very key part of the planning process. And so tools such as the one you see on the right help you to plan the appropriate route for a particular pipeline. It takes into consideration all the different things that you must be aware of, maybe population densities, maybe availability of land, maybe certain restrictions in the area that exist. All these things can be weighted using the little slider bars that you see here to help you determine for a particular area where you would find the best route for a particular pipeline. So this is a type of application that's very valuable in the planning of a potential new pipeline. So this gives you some really powerful examples of queries to databases that are connected to PODS, applications that connect to PODS and allow you to interact with PODS data in a very user-friendly way, one that might be more job specific for you, and help you make the most of your investment in PODS. So we'll leave the tabular side of analysis here and move over to looking at the spatial analysis side. So getting answers to spatial questions is possible by spatializing the PODS data. Again, we're going back to linear referencing, which is making that pipeline system data accessible for mapping and spatial queries, such as the example you see above. Sometimes the simple act of simply colorizing data or symbolizing data can be considered an analytical technique. So in this particular analysis that you can see the questions being posed are finding the closest valves upstream and downstream to this location highlighted in yellow. So you can see those valves that meet that criteria. And then if you want to drill down, for example, and learn more about these types of valves, you can get information by posing another query and seeing that this is a valve that's in the GIS system, and this is an ILI valve. So this is a very simple diagram here, just to give you the idea that we're dealing with spatial data at this point, and it also is getting fuel from the PODS database. So these features are appearing on the map because they've been linear referenced. And you can use a GIS software such as Esri GIS, and you can use these types of tools to conduct various types of analysis, including spatial analysis. And this is a very simple case here, but you can get very, very complex. Here's another example. So in this case, this is actually a flood scenario where imagery has been analyzed to determine areas or some of the work sites that were impacted by by flooding in Colorado several years ago. And so you can see the imagery analysis has been performed with GIS, and it has determined the areas where flood damage has occurred to these facilities. The symbology or the symbolization and coloring of these rings that you see indicate those features that are underwater, that have been flooded, versus those that have not been impacted by flooding. So it's not just when we're talking about spatial analysis, sometimes it also involves using imagery as a backdrop for your analysis, and then conducting various different analytical tools that work on imagery to determine certain conditions. So in the GIS world, you can work with vector data, lines, points, polygons, as well as imagery data, or sometimes people refer to these as raster data sources. So in this case, you can see areas, pad sites, and other equipment sites that are completely underwater and those that are completely dry. So there's other types of spatial questions that PODS users are asking of their data. Any GIS system like the one you see here, this is a screenshot from Arcgis. You can see that the pipeline in the graphic has been symbolized by color based upon what type of coding exists. So you can see coding type 1, 2, and 3 there. You can see how those colors change along the line and get a very easy idea just by looking at the change in color, how coding types are changing along the length of that line. But you can also ask some other questions of this data. So using analytical techniques in GIS, you can find out where's the nearest control station to a particular valve, or how long is the longest segment of this class 2 coding that you see. So it's very important to be able to analyze pipeline data spatially as well as tabularly. And I hope you're getting an idea that there are many, many tools out there that can be used to analyze pipeline data coming from PODS. One last slide before we move on to the presentation. So in this case, we're looking at 2 GIS layers. You can see a colorized pipeline. It's symbolized by MAOP. Remember, maximum allowable operating pressure, symbolized as linear events. So you can see the line changing symbology, but then also the circles are symbolized by their pressure rating values. So as you think about this, it requires a little bit of spatial thinking on your part to think spatially. What kinds of questions would you pose to the database that would help you understand more about this pipeline and the features around it or attached to it? So this is an open question for you maybe to think about. If you don't have the opportunity to work with GIS, or you haven't really thought about spatial questions, don't be afraid of this. You ask spatial questions all the time, but thinking about them with pipeline data might be something new for you. So at this point, maybe sometime after you've downloaded the presentation, come back to this slide and just think for a few minutes about the various types of spatial questions that you might ask about this data. What's near? What's nearest? what's far, how long something is, or what's the spacing between certain types of valves, and so on and so forth. So there's a lot of questions that you can sit and list, but the exercise here is to exercise your mind spatially, to begin thinking about spatial concepts and spatial relationships. So at this point, I'm going to end this presentation, and I think I've left ample time for our presenters today. So Jackie Smith, who was introduced earlier, is going to take over, and she is going to provide a lightning talk. Jackie?
Yeah, hi, can you all hear me?
Yeah.
Okay, great. And you see my screen?
Sure do.
Great, thanks, Julie, appreciate it. All right, so if we have any questions and answers for the PODS discussion, we can definitely do that at the end. So I'm Jackie Smith. Again, I'm the president of PODS, and that is a volunteer position. So right now I'm in my, put on my different hat. I put on my day job hat. I work for Rosen. Rosen Group, I'll tell you a little bit about them, but our lightning talk today is going to be about using ILI data to improve your PODS data. This presentation was submitted by Tad Nowicki, who was not able to join us today, but he helped author the presentation. And then I have my team member, Marcelio Torres, who is a senior application specialist. He's been with Rosen for over 5 years now, and he will present more of a demo style after I'm done with my section.
Hey, Jackie, you might want to swap screens.
Oh, okay, great. And I will do that. So you see my with my notes?
I do.
Okay, I thought we did this last time. Okay, let me try to figure this out here. Swap screens. Okay. All right, can you see anything at all?
There is no PowerPoint in front of us right now.
Okay, now.
Yep, you're good, you're good.
All right, cool. Okay. Okay, back to our regular scheduled program. All right, introduce Rosen. So we are privately owned since 1981. It's a German company, started out of Germany, Lingen, Germany. Right now we have offices in 20 countries. We have over 3,500 employees. And we've expanded in the US. We have about 400 employees here in Houston and in Columbus, Ohio. And then we also have an R&D campus in Lingen, an engineering hub in Newcastle. Those are some of the highlights of the company I wanted to talk about. Rosen is known in the integrity engineering space for its inline inspection tools, or PIGs, as you may have heard them referred to, an ILI tool. So they're mostly known in this inspection or diagnostic solution area here, this first red circle. There are other areas to Rosen here on the screen. We have process control systems and enhanced materials. However, the group that I sit in is integrity solutions. Here, the second red circle, and this is where we have our integrity management services and our systems, such as software solutions and GIS consulting, to name a few things. Today, we're here to talk about one specific area, pipeline data, specifically the value that we can add from ILI data and how we can improve the data within your operators' PODS databases. So what are some pipeline data sources? Pipeline data and information can come from a variety of sources. Most would say that as-built or weld maps are the most traceable, verifiable, or complete. This TVC topic was explained well last week by Petro IT. Those records have to be made before the pipeline is buried. However, once the pipeline is buried, very few options remain that do not require digging up the pipeline, excavation, which is expensive and introduces the risk of external damage, more external damage and health and safety issues. So it is another way that we can gather data after the pipeline has been buried. So this is where the ILI technology, or the PIG, would come in. We can use ILI technology, which ILI stands for inline inspection, as a form of non-destructive testing approved by PHMSA. So we heard about PHMSA in Julie's slides. They're our regulatory authority in the United States. And a non-destructive method is to run an inline inspection tool inside the pipeline. You can also, once you download this presentation or watch this webinar, you can click on this video to get a lot of information about running a PIG in a pipeline. Gives you a little show and tell there. Basically, the tool is placed in a launcher. Launcher and receiver you'll recognize from PODS terminology. Those are stored in the PODS data model. You run that through the pipeline. It generates a ton of data readings stored on the actual tool itself. And that tool is extracted at a receiver, and data from the sensors is checked. And then what's resulting is a pipe tally, which is a consolidated information provided by the in-house team at Rosen that evaluates the raw ILI data feeds. So the data is captured, and this can be put into your pipe attribute information in your PODS model. You'll recognize PODS 5 pipe segment table, perhaps here in blue. Tracks things like wall thickness and outside diameter. Your fitting location along the line and your attribute information can also be recouped from this ILI data that comes from that PIG. You get your girth weld locations, your valves, flanges, casings, sleeves, tees, taps. Again, more things you may recognize from your PODS training or your PODS implementation at your company. The center line XYZ coordinates of all these things can be gathered if you run a tool that has an IMU unit. And the IMU unit you may recognize from it's in cameras and drones and things to capture location. So what do you do with all this data? Once you have that standard data in a format that you can use and you align it to the ILI pipe tally, to the PODS or the GIS center line. We're able to use common systems to start to assess the data. The system that Rosen has developed to do this is called NEMA. You can see the bullet points here. It can be on-premise or hosted in the cloud. It integrates Esri GIS. It enables your entire organization to work with data. However, it is more of an integrity engineer's playground. It's Python-based, and it is based on continuous improvement, plan, do, check, act. So you're able to do iterations to really improve your analysis and your data work. So I guess what I'd like to do is just turn it over to Marsilio now, and he can show you a use case of how we've developed this NEMA platform to help us check our ILI data against our PODS data and fill those gaps. So let me end my slideshow here, and hopefully y'all can, there you go. Thanks.
Okay, can you all see my screen right now? The dashboard with the map?
Perfect.
Yes, I can see it, thanks.
Cool. So again, good morning. I'm Marcelo Torres, working with Jackie and Rosen. Again, I'm Senior Application Specialist, been with Rosen for over like 5 years. And what I do have in front of you is what the NEMA software is. And just to make it very clear, the objective here was to basically use the inline inspection data to compare to an existing PODS database, so we can try to use the inline inspection data to improve the quality of the PODS database. So as we said, or Jackie explained on the previous slides, this software itself, it is configurable, and we can set things to be step driven, meaning that our goal is to get our data better, and the application itself will guide you through the steps to complete or to achieve this goal. So here what I have in front of you right now is a very basic map, because what we're doing right now is, let's say that we did have our PODS database built, let's say 10 years ago, for example, using SBuild or whatever technology we had back in the day. But now we ran an inline inspection, meaning that we did have a tool that ran through all this pipeline with a unit inside that actually got the coordinates, right? So what we're trying to do with this thing right now, we did plot what was identified in the inline inspection versus what we did have on pods. So with this map, we would at least have an idea like, is the pipeline still in the same place or is it rerouted or something like that? And if we believe that this is acceptable, we could do something about it, right? But this is, again, these are just tools that would help or like support the GIS analyst in making decisions, because usually if you have a big PODS database and you want to fix it or improve it, you ask yourself, where do I start, right? So here, for example, is just very basic. You will see that the the darker line is the route where the actual pig went through, and the orange line is actually where the PODS database had in the past. So you see that we have like small discrepancies in here, but if you think this was inspected 15 years after it was built, we could say that is pretty acceptable, right? And also what we do have in the same part right here is, we imagine that if we roll this pipeline as a single thing, it was going from start to end, we plot what was identified in the PODS database and the assets along this line, so we can have some comparison of what we're looking for and what we're trying to help with these things right here, right? So you can see that if we have like a dynamic that we can zoom in things and get closer looks to see how the data does behave on that particular point. And we could see that, for example, on this portion of the pipe, we do have the joint numbers, we do have some wells that were here, we have a valve, and we can see already that we did have a ILI, the wall thickness that was identified in here, but we didn't have anything on the actual PODS database, right? And so once we do that, we're okay with the route. We can see some comparisons. What can we do next, right? So once we start the actual analysis, we could run a procedure or a count or a query that will just break down what was identified, what was detected on the ILI versus what we had on the GIS, right? And here with the use of Python, we do have the counts, so we can start to find some discrepancies. And here what we're trying to do is we're trying to use the ILI as the master or where we're trying to go to, but we can see that we do have, for example, 46 markers that were identified in the ILI versus only 14 that was built when PODS database was built. So that could be newer installations, newer updates, and stuff like that. And here again, we do have what we call the linear comparison, where we put this on charts and we start comparing them to see which ones match and which ones did not match. And here, for example, we can see that there's this valve right here that matched with this one right here. And of course, we are using some tolerances like 100 feet or something just to make sure that we actually have like a margin of error, because we don't expect them to be 100% match. But this is starting to tell us that there is some data on the inline inspection that happened or was updated over this past 10 years that was still not in the PODS database. So this is just a start, right? And moving forward, this we're doing with the pipeline fixtures, tees, taps, valves, and etc. But we can also use this to compare the actual pipeline properties, such as the wall thicknesses and the diameter, right? So here we could see where it did match and where it did not match. But right now we can see that there's not a lot of matches because the PODS database probably was not built with the correct information. So you see that there's a lot of variation in the wall thickness that was detected on the inline inspection that was not reflected on the PODS database, right? So again, with this three first steps is just comparison, is just showing you what you can see, but what can you do about it, right? And here, what we start to do is we ran again a procedure in Python that what is doing is getting those pipeline fixtures that were identified on the ILI, and we're bringing that into the PODS structure. Again, the software is not telling you what to do, but that's at least a start, right? So if there's, for example, here, we do have the route, the start and end, where does that fall, all in the PODS structure. And this is what we had in PODS before, and this is what we, based on the inline inspection, what we're suggesting that should be added on the PODS database from the inline inspection, right? So this is where we actually start to, after we find the discrepancies, we start to take action to correct the database. And here, the same type of analysis, we do that with the pipe properties, meaning that if we found those wall thicknesses in the ILI that were not in the PODS database, we now bring those measures into the PODS schema so we can update the database back and actually have more accurate data. And how we're doing that right now, we use this as an export. So we bring the PODS database into NEMA, we process these analyses, and we export back the results. So the person which is actually responsible for the data in PODS can assess if they want to put this back in PODS or not. So again, just to make this very, again, the objective again is we have a PODS database that we know it's not up to date or has some work done on it. We do have an inline inspection data set which has data that's more recent. So what we're doing here, we're just trying to use the inline inspection data to update our PODS database to make the PODS database more accurate. And we're using the Rosen NEMA software as a tool to get us started, to at least automate some of that heavy lifting work, so the people that actually is doing the analysis only need to care about the actual analysis and not putting everything together. And this is what I had to present for now. And if you have any questions, or I guess I'm switching back to Jackie or Kathy, but this is what I had to present from the Rosen side.
Marcilio, thank you so much.
Yep.
We are a little bit over. We do have a couple of questions, and I'd like to, for those who can still stick around, I'd like to ask one of our presenters one or two of these questions. Is the imagery utilized for GIS analysis updated on a daily basis to ascertain any damage caused by a natural disaster such as a cyclone or flooding? So really the question is how is it updated? How often is it updated? If you could address that.
Yeah, I mean, I can address that. I used to work for an operator for Williams, and the aerial photography, it just depends on how they've, who they've contracted with. Most of the time, that data is not updated that often, and sometimes it just depends on the need. A lot of times, yeah, go ahead, Julie.
So I used to work for Digital Globe, which is a satellite imaging company, and I will say that it is, in cases of widespread disasters like hurricanes and typhoons and things of that nature, there are operators that do produce data. You know, maybe not every day, but certainly aerial flights can take place many times throughout the day, and they do take place many times during the day. The federal government, if it's a U.S. Storm or calamity that takes place, you'll see that most government agencies will have access to that daily updated data. There is a small, there's a satellite operator called Planet, and they also have pretty short turnaround on their satellite data, but most satellites have to be pre-positioned, and so it's not usually a 24-hour turnaround, but it could be shorter timelines, like maybe once or twice a week or something like that. Aerial is probably, or drone is probably going to be the quickest update source.
Thank you. There's also somebody who would like to have an example of a search of data based on pipeline KP values. How could we get him an answer offline?
Yeah, I would get him an answer offline, Kathy.
Thank you. And then one last question from Ronaldo with ExxonMobil. How often would you run an ILI with a pig so that you would get more info to make sure that what is collected is indeed more accurate?
Yeah, you can, I'm not sure exactly how often the ILI tools are run, not in that area, but they can run them, as often as they need to. They're not, they're, unfortunately, I don't think they're very inexpensive. I think running an ILI tool is pretty expensive. So if it's depending on the type of tool, actually, but there are some that you can run annually. That
Yeah,
are cost effective to run annually. Mm-hmm.
yeah, it does depend on like where does the pipeline is running through, and also about regulations, or there's like could be either 3 or 5 every 5 years. And I think I can also, there's another question from Reynaldo at first where it says bom dia, and I can also say bom dia para você também, but that's kind of how it is. It really depends on what product does the pipeline transport, but if you want to run every year, if you can pay for it, it's entirely up to you. But ideally, it would be either like 3 years or 5 years or 7 years, depending on how critical the pipeline is and what the product it does transport.
Thank you, Marcelio. So with that, we're going to conclude Unit 5. I'd like to thank Julie Parker. I'd like to thank those who provided the lightning talk, both Marcelio and Jackie. We appreciate it. I just think that the presentations to date have really underscored the importance of a data standard to pipeline operations, maintenance, and overall data management. PODS has been developed by seasoned pipeline operators with really decades of experience, and PODS data standards and data models are approved through a consensus of our membership. So what you get as a user is standards and models that are really well thought out, and those by those who are committed to continuous improvement, which is what we see with PODS 7. And you'll be hearing more about that as we move forward. So thank you for attending. Next week is Unit 6, our final presentation in PODS Basics, and we look forward to seeing you then. Thank you and have a great week.